Okay, so we have done two things. We have done the recording and we have done the sampling. The next thing we need, as you can see in this block diagram, is once the speech signal is recorded, we are doing the feature extraction. And although people have proposed different features over time, MFCC is still one of the most famous feature. So what is MFCC? MFCC, basically the full form is male frequency substrate coefficient. And the block diagram of MFCC is something like this. So we do a fast Fourier transform where we convert the time domain signal to frequency domain. We do some Mel scale filtering. As you can see here, this is the filter we apply. We do log and then we do DCT to get inverse Fourier transform. And finally, we get coefficient. So the math, you don't really need to go deep into the math, but you should have a basic understanding. But the important thing is how to apply it, right? And so for the application part, again, we will go to the collab. Right, so again, we will import all these important libraries. Librosa is for audio signal processing. Matplot is for all the mathematical part and plotting. NumPy is also for mathematical processing. So now we read this file, English underscore 16K. We read the sampling rate and everything, audio length and number of feature. By default, it is 13, but you can also go for 26 and 39. In the class, we discuss what is the use of 26 and 39. You can also Google out or chat GPT and find out the difference. The more features means more, it will capture more information, right? So let us try 39 now because already I did 13 in the class. The rest of the code is already there in the chat. You simply copy it and you paste it and you run it. So once you run it, you can see here, it gives me all the features and I think it is still running. Yeah, it is also giving me the MFCC coefficient. On the x-axis, we have the time. On the y-axis, we have the coefficient. So now we have gone for 39. In the class, we discussed 13. Right? So you can see here all the details of your wave file are mentioned here. Yes, and these are the features. This will not make sense to the naked eyes because most of the processing happens in spectral domain. Eventually, it works very fast, very nicely for the ASR part. Okay, so that's all in the second lecture, which we covered. In the next lecture, we will see the annotation using the LR.